All right, Unit 6, Day 4, Vectors, Part 2. Vectors, Part 2. Yesterday we did adding and subtracting vectors, multiplying by 3 or 2, scalar multiplication. Today we're going to multiply vectors. And the, I guess, extra weird thing is that there's 2 different types of multiplying. And that's new to us because we've got different symbols for multiplying already. Like we know 3.5 is 15 and 3 cross 5 is 15. Like it doesn't, that's just multiplying. That doesn't matter. But with vectors, those symbols are different things. It's a dot product compared to a cross product. The good news for us is we're only going to do dot products, so you're not going to get them confused. We're not even going to do cross products. They're much more, I don't know, confusing is the right word, more involved for sure. Dot products are pretty easy, so we're going to stick with dot product. But that offers some explanation as why there's different symbols for multiplication. Is in other areas, like vectors, they mean different things. With just numbers, they mean the same thing. All right, let's say u equals 5, 3, and v equals negative 2, 6. And here's how we take the dot product of u and v. It's product, so you should know that multiplication is involved. We're going to multiply the x's. So 5 times negative 2. And then we're going to multiply the y's. So 3 times 6. And we're going to add the results together. So that's kind of the extra weird part about this. You're like, okay, multiply the x's, multiply the y's. That kind of makes sense because we're multiplying. But then we take both of those products and add them together. So negative 10 plus 18 equals 8. So the dot product of u and v is 8. Which may seem a little bit weird. We multiply 2 vectors and we end up with 1 number. So our answer is not a vector, it's just a number. Angle between vectors. The angle between vectors. It's kind of a complicated formula, but it's open note. By the way, even in years when it's not open note, we give you this formula because it's complicated enough to feel like we should give this to you. It's more about knowing how to use it, where the stuff goes, than just memorizing a formula. So the cosine of the angle between them is u dot v. So that's the dot product we were just talking about, over the length of u times the length of v. And you can if you want, but it doesn't matter because those are both numbers, right? That's a length, that's a length. So yeah, you can, but you don't have to. So that's the formula. I'm not box, well, you mean, again, it's open note, so box it so you can find it, I guess, but you'll have it available to you. If you prefer, maybe it helps to see it as like a word formula. That's the dot product over the product of lengths. I mean, that's not anything new or different. It's just a different way to say what the formula is. Some of the less mathy people prefer a word formula to a symbol formula. Let's find the angle between u equals negative 3I plus j and v equals 5, 2. And yes, I intentionally sort of crossed up the formats there just to get us used to handling IJ format and the ordered pair format, because it doesn't matter. If it bugs you, switch them both to 1. So I need to find all these pieces, and then we'll go to the formula. So I can't really jump to the formula yet. I need to find the pieces first. And the pieces are kind of complicated on their own. So this is one place where showing your work is going to be important to getting all the points on the test. You can't just write down the angle. You've got to show me how you got there. So the dot product, negative 3 times 5, plus 1 times 2. Right, so multiply the x's, multiply the y's, add them together. So we got an extra, or another dot product practice problem sneaked in there. The length of u, that would be the square root of a squared plus b squared for u. Again with the negative, so please be careful. Coefficient of j is 1, not 0. You know that. Again, here's where using your brain is probably better than using your calculator. Because if you use your calculator, somebody's going to get negative 8 under the radical. If I use my brain, I know if I square negative 3, I get 9. Plus 1 is 10. So square root of 10. And I don't want to write that one as a decimal because I'm going to use that later. So I want to keep that as an exact answer. In fact, even if it would reduce, so even if it was like square root of 12, I would leave it as square root of 12 because we're headed toward this formula and a calculator anyway. So why bother simplifying, even if it will? Just leave it alone. Length of v, square root of 5 squared plus 2 squared. 25 plus 4 is 29. So now I got all my pieces. Now I can put them together into the formula. Cosine of theta. Now it's just making sure you put them in the right spot. The dot product was negative 13. The length of u was square root of 10. And the length of v, square root of 29. Does anybody remember how to go backwards? Like I'm looking for an angle, so I don't want to take the cosine of all this. I want to find an angle whose cosine is that. So do you remember how I undo a cosine on the calculator?
Unsquare it.
Uncosine it?
Uncosine.
Uncosine it is kind of right.
Like second then cosine.
But that means second cosine. That gets you the inverse cosine.
Yeah.
Which is uncosining is not technically correct, but that's a very good way to say it. So I want to uncosine all of that. This would be another good place to use the fraction bar in the calculator so that you don't mess up the parentheses. Oh, before we go there, make sure you're in degree mode.
Oh yeah. I don't know why kids.
Why am I getting weird answers? Well, you're probably in radian.
I
So.
don't know why kids they'll set the calculators back to radian even though we're in physics. Like, why do you have it on that. Stop it.
If you clear a calculator, it goes back to radians.
Yeah, if you
That's
set
annoying.
Default, it goes back to normal.
Default is radians. So if you grab one of mine, you want to check it. If someone before you had it, they may be in degrees, but you should check
You should check it no matter
just to
what,
make
because
sure.
You may be in geometry and some nerds that may set it to radians.
So inverse cosine.
Set degree when you're not radian.
I'm going to use the fraction thing because I think that'll help me from making a parentheses mistake. Negative 13, square root of 10. Be careful, don't just go square root, because now you got the square root of a square root, so you can really mess that up if you're not paying attention. So arrow out of that square root, then do your other square root. I mean, if you're watching, you'll see that happens and you can go fix it. So the angle between them is 139.8. That would be an obtuse angle. Correct.
Do you ever need like radians specifically for something?
Calculus is when you need radians specifically. There's a long answer to that question, but calculus is the short answer. All right, Roman numeral 3. I debated whether to cut this because you don't really need this. You could get by without it, but it makes things a little bit shorter, a little bit easier. So we'll do it, and if you don't like it, you can get around it by finding the angle for everything. But finding the angle is kind of a pain. So if there's a shortcut, maybe we should know it. Oops. So first shortcut for perpendicular. Actually, let's back up a second. Parallel would be if your angle is 0 or 180. What's perpendicular mean?
Like opposite.
What is it in terms of angle measurements? Perpendicular. 90.
Oh, wait, no. It's 90.
So one way to answer the parallel, perpendicular, neither questions is to find the angle between them and then just say if it's parallel, perpendicular, or neither. But there is a little bit of a shortcut. For perpendicular, the dot product equals 0. So if you know that, if you're paying attention, the first step you would do anyway is find the dot product. If you get the dot product to 0, you can short circuit the whole thing and say that's 90 degrees, it's perpendicular. I'm not doing the full thing. And that's fine. That's why we teach you this. Parallel is a little bit trickier. Is if the two vectors are scalar multiples of each other. We probably need to see an example of that. The two vectors are scalar multiples of each other. So let's say we have 2, -3 and -4, 6. Scalar multiple means we multiply the x, whatever we multiplied to the x is the same number we multiplied to the y. And if those numbers are the same, then those two vectors are parallel to each other. So what would we multiply by to get from 2 to -4? -2. That's not x minus 2. It's supposed to be times -2. We'll just leave it as -2. How about from -3 to 6? What would we multiply by?
2
From -3 to 6?
or
-2. Well, since those numbers are the same, then those two vectors are parallel. Sometimes the multiplier is weird, and the little shortcut, you can't quite figure it out, and so you just kind of go the long way around. and see what you get for the angle. And there's nothing wrong with that. It's just sometimes you can catch it early and you're like, wait a minute, something's going on here. I recognize what's happening. This one is just a multiple of this one. That means they're going in the same direction, so they're parallel. So let's do 2 more problems and then we'll be done. So parallel, perpendicular in either for 2, -6 and 9, 3. Are they parallel? Let's answer that one first. Why no? You're shaking your head no. Yeah, I mean, I'm not sure what this multiple is. Maybe. That multiple would be -1/2. This multiple is definitely not -1/2. How about that for math? One of them's 1/2. One of them's not -1/2. So it's not parallel. The perpendicular check is the dot product. 2 times 9 plus -6 times 3. Dot product is 0, so they're perpendicular. Again, if you go through the full process of finding the angle, you would learn that they're 90 degrees, and then you'd say, oh, they're perpendicular. But if you know the shortcut, then you save yourself a little bit of time. Last one. 2i plus 3j -8i minus 12j. Parallel, perpendicular, or neither.
Wait, is so what we just did, the shortcut way?
Mm-hmm.
Okay.
Yeah, the long cut way is to find the angle for all of them, which is fine. It still works, but it's a little bit more work.
Yeah.
Shortcut, well, you got to know the shortcut, but it saves you some time. So it's kind of your call whether you want to do the shortcut or not. So what do we think about this one? How do I get from 2 to -8 with a multiplier?
-4.
And how do I get from 3 to -12 with a multiplier?
-4.
So what does that mean?
Parallel.
Those are parallel because they have the same multiplier. Again, if you go through the full angle thing, you're going to get 0 or 180, so you know they're parallel. But the shortcut, I think, makes life a little easier. You're now ready for Unit 6, Worksheet 4. All the odds are available in Schoology, so you can find them right there. And you online people, your test will be available on Thursday morning
A lot of notes.
with notes.
Wahoo.
And good luck.